So we are given this diagram. In the diagram, ABCD is 2/3 of the center as of the circle of center. Oh, we are given that the radius is 7. So each of these is 7. And they told us this angle here is 2/3. 2/3 of the total angle. The total angle is 360. So I'm saying that angle A, that's the total angle here, maybe ACE is 2/3 of the total angle, which is 360. So this should be 240 degrees. So what we have here, the angles here, the total is 240. But looking at this triangle, they are congruent. They told us that AB, BC, they are the same. So all these lengths are the same. So meaning they are congruent. These 4 triangles are congruent. So let's find each of the angle, which implies that angle AOB will be the same thing as angle BOC. The same thing as angle COD. The same thing as angle DOE. Which is now, since they are equal, we have 240/4. So each angle is 60 degrees. Each of them is 60, she's 60. So meaning this is 60, 60, 60, 60. So remember, they told us this side that are equal. So since this is 60 by isosceles triangle theorem, this should be 60 all through. So they're all 60, meaning that this length is 7. They are all 7, 7. So we have 4 equilateral triangle. So area now, the area of this is the total area of the sector minus the area of the triangle, and they have 4 equilateral triangles. So we have area shaded is now area of the sector minus area of the 4 triangles. So we have area of the sector is 240 degrees over 360 times pi r. Our radius is 7 squared minus 4 times area of the triangle. Remember, equilateral triangle is √3/4 side square, and our side is the radius, 7 squared. So we have 0, 0, 12 in that, 2 in this, 3. Remember, pi. This is 7 square. We have 7 square, 7 square. So we'll factor 7 square remaining here. √3, so minus √3 times 7 squared is 49. So this is our answer. That's our answer. Okay, we are given if these 2 circles are, if PQ is a common tangent to this circle, and their radii, that's the radius are 25 and 9 respectively, then the length of this tangent, common tangent, equals to dash. Without wasting time, the answer is 2 times 5 times. The answer is 30. But you'll be wondering, how come is it 30? The answer is 30. So see what I will do. Let me just do an analysis here. Assuming you have, as you can see, that the same circle. If I join the radius, assuming this is the bigger radius r, while this is the small radius r, and since they are tangent, this is a tangent line, so the tangent is always perpendicular to the radius. So this is angle 90. Again, joining this, you see this is small r and this is big R. Again, if you see, this line will be parallel to something like this. If you have, do you get, they are parallel. So assuming this line is parallel to this, so the same 90. So once we know this length, we've known this. So looking at this, we now have, maybe let's call here C. So we now have a right angle triangle CAB. So if we know this length, let's call it D. We've known PQ because they are the same. So, and common sense will tell us that since here is R, since this is parallel to this 90, this 90, this R, this line is parallel to this line, meaning this is small r, that's CP small r, while what is left here is big R minus R, such that if you add up this, it will give us the big R again. You see, so we'll form a right angle triangle now using Pythagorean theorem. So you see that from Pythagorean theorem, D is now square root. This is the hypotenuse, R plus R squared minus R squared. Yes. And from algebraic expression simplification, this is R, this is R, this is plus, this is minus. So as far as this is minus, this is square, this should reduce to 4RR. That is just a formula. So which is now square root of 4 is 2. Square root of 4 is 2, while square root, this one has no perfect square root. So that's the formula. So this is now the common tangent to a circle of this. So that's the formula. So as you can see from here now, our what we are looking for PQ, which is, that's PQ. PQ is now 2 times square root, what's square root 25 times square root 9. So this is 2 times 5 times 3. Our answer is 30. So it's very simple.